Hello explorers and welcome to another video. And today I'm gonna talk a little bit about Git. So I'm gonna do a Git commit. Hey! It's gonna be very exciting. And today I'm a little bit sick, so I haven't prepared this session at all. I know the prerequisites and so on, but I haven't done this before, so this would be some live coding and all the mistakes I know. Well, I do mistakes. So this will be pretty off the cuff, and I hope you like it. So what we want to do today is firstly a git init in this directory. So we have an actual git repository, and we want to do a git. We want to create a file. So I go hi to file. We don't want to commit everything. Perhaps you want to stage the file, and then you want to commit. We committed a file, and if we look here in our Git directory, we have a working directory, we have a file, and everything is committed and done. So this is what we want to accomplish, but we want to do it with Java. So first off, I want to delete this directory we have here. So this test directory is we will work in test2. Let's do that. Make dir test2. We can have as many tests as we like. So if we run git status here, it says to us that we don't have any git repository here. So we need to create one of those. So let's, in our code, firstly start by creating a directory, listing to this directory. So this is file c column temp test2, and I think front slashes will suffice better, so we don't have that issue. We will include file, and now we have a pointer to that directory. So in this directory we want to create some directories, and I think the easiest way to do that is to write file, the directory name, and what kind of directories we want to create in this directory. So we want to create git / objects. So that's something we want to create. Make dirs will create both of those. New file, we want to create a directory, and the child should be git /refs /heads, I believe. So we create those two. I think it actually, to initialize, we don't need to create a heads directory, we just need to have the refs directory. But why not have the refs heads as well? And you also in this heads directory have refs to tags. So heads are your branches, and tags are different tags in your directory listing. And last but not least, we need a new file in the directory, and the child should be git /head. And this head file, we actually need to write something to that. So let's create a file pointer to that. We say that that's our head. So let's see here. We want to write something. So we create the file writer fv new file writer head. Let's see what we can append here. We can append chars. That's exactly what we want to do. We want to append refs. So we want to put a reference. We want to create a reference to refs I believe we might not want that space. Refs, and then we want heads, and in this we want it to point to master, so the master branch in refs heads. And maybe we need a try catch around this. Is that why you are sad? No. Why are you sad? Yeah, unhandled IO exception. Catch exception. This is not production ready code, it's just something we try out. So let's see here if we can run this main function here. See what that does, if we get an error or if everything is just fine. Oh, I created a terminal. Everything was created fine. So let's do a git status. See what happens here. It's still not a git directory. So can we go to git? We need to have this a little bit wider so we actually see something. We have heads, objects, refs. Yeah, I see what I did there. So this needs to be closed, of course. You need to close your file pointer or else it will not write anything. There we have 21 bytes. And if we do a git status, we have our initial repository on branch master with nothing in it. So we have successfully created the first part. So now we want to do a commit as well. So, then we need to create some objects. And an object, in this case, is something that contains some data and then have a type and a length that is displayed as a header before that object, and then we deflate that in order to create the final data. So we would need to create a new static void create object. Do we want... Yeah, we don't want the file name. We want this to write the actual object, but we want to set the string data. So in here, we first off want to take this data and find the length of that data. So data length, yeah. So now we have the length of the string data that we want to append. And yeah, we need a type. We need a type. Type. So a type is if it's a blob, which is actually some data. You just put in some data. You could have a tree object, and that's to define directory structures or your files. And last but not least, you have the commit type, which is the actual commit that we will do later. So here we want to create some new string data. String, let's say file data, and this we want to be first the type, and then I think it's space between that, and then length, and last but not least we want a null character, and after that we want our data. So that's how the object is done. And this file data that we have now, we want to make a hash for that. So we don't want to make a hash on the actual data that is deflated. We want to make a hash of the file data before we deflate it. So here we now want to create message digest md new message digest. Oh, we don't want to do that. How do we create a message digest That's not what I want to do. Get instance of SHA-1. And that could crash because there might not be a SHA-1. So we will try to do that. Catch exception. Catch it all. You gotta catch them all. So there we go. And we want to digest our byte input. We could do that. Yeah, so the file data get bytes. So now we will have the byte array digest. Problem we have now is that we need the bytes in hex. So byte to hex. Let me search for that. Byte array to hex string Java. Convert a byte array to hex string in Java. Yeah, we can do a string builder of some sort. There's a lot of different answers, but a string format, that sounds like an awesome solution. Like that. So then we have a string here, which is the answer of that formatting. Nice. Very nice. Yeah. So now we have this hex. And in the Git repository, just because you don't want too many files in your objects directory, you actually put your object in a directory which is the first 2 characters of the hash, and then use the rest of the hash as the rest of the file name. So I think we need to have this file directory as well, and that could actually be the object directory. Yeah, so we don't need to actually go anywhere. That would be nice. So if we are in the object directory, we want to create a directory. So file, new file, there, and this should be the first 2 characters of my hash. So substring, beginning index, the first 2. There we go. So that's our directory that we want to create. Make dir. Yep. And so this is the object dir. And in that we want to create a new file, object dir, with the rest of the hash. So that's where we want to put all our data. So this is the object file where we want to put all the datas. And now we need to deflate our data. So deflate is actually just zip down your data with libzip. So it's not a fancy zip function, but it's good so you keep these kinds of data very small, because in the case of source code you usually have very small objects, or at least you have a lot of texts in them, so you want them to keep them small. So deflator is a good name. New deflator. Could that be something? Deflator. Deflate. And we take the file data, get bytes. So this is what we want to put in our object file. So we will again create a file writer, object file, no, file writer, let's call it that. not a good naming scheme, I know, but this is just for show. And we want to add pen or write or something. Sure. Could that be something? Oh, it accepts it. Great. Close. Done, done, done. And we actually want to give back the hash because we want to use that later. So let's return S. We can call that file hash string file hash null. Hopefully it never will be null. Hopefully it always will have a value when we return, or else what? Exactly. Yeah. So that's pretty much it. We have a function where we can create an object in a directory with some data in it. So first off, we want to create that object. Let me check something here. So I remember the file structures, so I don't do something bad here. But the first file I remember, I think, is just to put some data in an object. So let's just put some small string in here. We want the directory of the objects. New. Actually, we want this file to be objects dir. We want this file to be why didn't you want that to be the case? This file to be heads dir. What? Because we do these directly, we get booleans back. So object dir make dirs head dir make dirs. So there we go. So we will create an object in the object dir. So first part is the type, so this is a type of blob, and we have data. Let's do some small 10 print, and here we want to do something like this: hello world, just to keep it retro. So now we have created our file with some data in it. So let's see if we have, there should be a function to read the object file, cat file, yeah. So let's see if we can do that. Okay, we forgot something. And we have the same problem here, right? Why didn't it tell me that that was an issue? Make yours like that. So still have an issue. Yeah, we haven't renamed all these strings. That could be an issue. So there we go. Illegal conversion exception. Okay. In the formatter. So why can't we use formatter to get our hash? x not equal to that. Byte array to hex string in Java. How do I convert a byte array to string? Bytes to hex. This looks like a stable one. An oldie but goodie. So let's put that there. Let's not make it complicated. We just want some bytes to hex. It shouldn't be that hard, right? So that's finished. So we will get into the Git directory. Yeah, the object directory, and we have 18. Yeah, and we have a file here with 1. That's not okay, right? So this write did not write what I thought it wrote. Let's go out here and fetch the byte array that we got. Deflated bytes. That. And let's see what we can do with write. So file writer can write chars, char buff. Yeah, but then it needs an offset. So this will return. No, it returns an int. Hello there, deflator. How do you work? Deflate. Could be good to read the actual deflator compressor. Set input, finish, and then deflate output, and you will get your output there. So the interface of this deflator was a bit more convoluted. So we will set our input. This is here, bytes, and we will get a compress length here. Okay, and I think we can remove, if we find there. So we have a little bit more space. So this deflator will deflate to this output buffer and get data length. So we will write the output from 0 to length. So that should give us a little bit more. What? Write char buff offset. Okay, you didn't like char. Buffered file. Buffered writer db new buffered writer object file. Or do you want a file writer? Yeah. And this write still just char buff. Write byte array to file in Java. Yes. File output stream. That looks promising. File output stream. Fuzz. New file output stream. Object file. Fuzz. Write byte array. No, we don't want to do that. Write byte array with an offset, because we want to say how long it is. 0. compress data length, and then we say foos, close. Let's see if that's better. It should be the same. Yeah, now we have a little bit more. So then, if I go back to this here, I should be able to say git cat file-p and then say 18 plus this hash up here. So mark this little doohickey, paste it down here, and we have hello world. Nice. And if we go in here, objects 18, do we have a cat? We don't have a cat. Yeah, it's probably not hello world, as it's 39 characters. We can also do this cat file and ask for the type, and it says blob. And I also think we can ask for the length, size -s, so 23 characters. So we have written a blob. We have successfully done that. So now we need to make a file listing. So what shall we call our little file then? We need to create another object. Create object. So this should be string data hash. So this is the hash we get back for our data. And here we want to create something in the object there. And this should be file hash. So this is the hash of the actual file that we create. And this should be a tree, of type tree. And the data. This is a little bit interesting. First off, we can create a file with the actual permission it needs in the system. And to do that, we will create a string, and first off, say we can say file data. So in this string, we first want to have 100, and then 644. And if you have worked with files in Unix, you know that 644 stands for read write, read read. So that's how to interpret that. Then we want blob, because this is a blob in our tree structure. And then we want to give it the data hash. And then I believe there should be I think this part here should be either a few spaces, or it's just a tab character. I'm not really sure. Let's try a tab character. We copy paste the spaces here. I think they are right on it. Like that. And then we need to give the file a name. So this should be, let's say, print func. It should be a Pascal or a QBasic. Let's call it a QBasic file. So print func QBasic. So that's our file data in our tree. So, and this will create a file listing in Git, hopefully. So if we go just git status here, we still don't see anything. But I think if we create this tree here, we should have an actual file name. Will we see anything there? We will not. Let's look at the object that we created. Let's see if we can look at that. Let's go into the Git directory, objects. So we have E18. We have 81 there. Go back. do git cat file -p e8 and this new file that we created and see what's in there. Corrupt file. So that was not the correct file format. Let's try a tab character instead and see if that's the actual format we want. No. Corrupt tree file. So if we ask about tree, it says the type, it says tree, it says it's 71, but it's still a corrupt one. Why is it corrupt? Do the actual hashes need to be lowercase, perhaps? Let's do that. So we just change this function A, B, C, D, E, F, G. Hopefully that will give us lowercase instead. And here, git objects. Yeah. Oh. We got different hashes. Why did we get different hashes? Are you sure? Yes. Yes. Okay, del3. Is that how you do it? Me and Windows. Delete specific files. Quiet mode. Attributes. Read only. Nope. I can't be bothered, so I do it with a GUI tool. Command line in Windows are not my favorites. So let's remove all the objects like that and rerun this. Illegal start of expression. What did I do? Is that better? I probably added something that I shouldn't. So now we have 18 and 9f. Yeah. So let's try that instead. Git cat file -p 9f, and then we do like this. We go here. Mark this one. Paste. Yeah. Nope. Let's not make this so hard. Let's go back and create the tree object. So this will return string again, and it will return hash file. Like that. No, it can't. Yeah. Let's create a tree. Remove this type. Let's create blob. Put the blob type in here. that. And the data, in this case, needs to be string file name byte SHA and string mode. So the length will be equal to mode length plus file name length plus 20, which should be the number of bytes, plus, let's see here, we have one space and one 0 character, so that should be 2. This is very, very, very unclean, because we don't really want to do it like this, but okay. We put mode here, and then we put file name. We should have a space between them, and then a 0 character. Then we do the digest. We md update, and we put all the file data here in the update. Get those bytes, and then we do digest with the last SHA value here. That's just a bunch of bytes. And we need to copy the file hash as well. There we go. So this should, with a little luck, create a correct set input. Byte input stream, byte array input stream, new byte array input stream. No, output stream. Output stream. Output stream. Output stream. Buzz. Write byte. Write the byte. And we get those, and then we write the byte of the digest. No. 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 SHA comes second. File data come first. Get bytes. So the SHA will we write here. Mice get the array. So that could be something. And we have a create blob here without any blob object. And we create a tree down here. And it needs to have file name, mode file name, and bytes. So this needs to have mode of 4, and we need the file name, so let's call it test and data hash. That should be good. We got a different hash. Cat file -p, paste, and we got it. We got it. Yes, finally. So now we have a tree file. So I wonder if the commit is as troublesome to get there. Git commit blob function here. We will put back the string type here. With a little bit of luck we can reuse it. Maybe it was just a tree file that was strangely hard to do. Create object. But we learned a lot about tree files. So we create object there, we created a tree file, we got a file hash back, now we need to create a commit. And a commit is pretty much a bunch of data, very simply put, the author and the committer and some dates when it happened and the message. And I will copy this strange text from the internet. So I have something, and I think these might be actually like these. So let's hope this is the structure. It looks very much like an email message, which looks fine. Yeah, so in order to create a commit then, if this is to be believed, we will need to have this create object that we have up here. We add the type up here again, blob, and we add the type commit, like that, and we have some commit data, and the commit string commit data should be equal to what? We need the tree, and that should be this file hash, right? Comes from commit, yeah. And then after that we need something like that. Let's continue with this commit data, add some more stuff. We should have an author. Author, Daniel, person, author at example.com. 0 plus 0, 0. So that's the time code. And then more commit data. We need to put the committer. Daniel, person, still a committer at example.com. And let's just put some bad dates there as well. Commit data first, commit message, and we put some ends to that. And this hash we call the commit hash. So we have that. Let's try that out. So the last git cat file-p, this last commit. We actually have a commit. That's really good. Which means that we can go back and update our refs directory. So we have this heads directory up here. And so file master equals. So if we do a git status here, we don't have a commit yet in our directory. And that's because we don't have the master branch actually pointing to a commit yet, but that's what we want to fix now. So the head steer, we want to add the master file. So let's just take a simple file writer there. If we new file writer to master. If we write, and then we want to write this commit hash. So bytex commit hash, and if we close is if we already used, yes. So let's take the very controversial name fv2 and run that. Hey! We gotta commit. So after a lot of work, we actually got a commit, and if we git checkout test.txt, git checkout dot git reset status, git checkout test.txt. Yeah. So we actually have this text txt, and if we open file, probably could use a simpler command program than that. Let's open the Notepad program. That was a while since I used that. We go into the temp directory, test directory, and test. Print hello world. So we actually got the file back from our Git repository. So this took a long while to do. I didn't really understand that we didn't want to have the actual hash of the hex hash in the tree files. The tree files were a bit strange, that you really needed to have the specific bytes of your commit in your commit or in your tree file, which made things a little bit strange and took a bit of time to understand. So to recap, what have we done today? We have in the our temp directory created a git objects, we have created git refs heads, and we have created a head file. And in this head file we added a reference to the refs heads master, which is the actual branch we are referring to now. So our head is pointing to the master branch. And after we've done this, we had actually initialized our Git repository. So the Git repository could be used to actually check in things, because this is the pure minimum things you need to initialize a repository. But our master isn't actually pointing to anything, so I wanted to take it a step further and actually commit something into master. And in order to do that, I wanted to create, and I needed to create an object, a blob, and I created it with the data of 10 print hello world. And in order to then have this blob that I created to actually be added, I needed to actually give it a file name. So you could have objects in your Git repository without a file name, but I wanted to be able to check it out later. So I created a file name with a mode of 644, the file name of test.txt, and the data hash. The data hash I got from here, and the reason I needed to actually give it the actual bytes from the object creation is that this tree object has the mode, space, the file name, then a 0 character or a null character, and then the bytes of the actual object, the 20 bytes, not the hash, not the hex value of those bytes. So I couldn't create a string of it, so I gave it all the data and created it inside of the function. Then I wanted to create my little git commit message here. Here I could actually use the hex value of the tree. That was fine. And I set an author to it, a committer. So when you are dealing with Git, you can have somebody that actually wrote the code and then another person that commits it. And that's when you are branching or when you are taking code from other people. And then you have my first commit message. And I create an object for that as well, a commit. And I then must create this master reference point that we earlier referenced in our head file. So this master file in the heads directory, I wrote it down with the commit hash, and after I've done that, I actually have a Git repository with one commit. If I do a git log, it should print out commit Daniel Persson and the date, which is actually in the 1970s because I set it to date 0, and this is my first commit message. So this was what I wanted to talk about today. I will cut away some parts where I actually figure out how the tree structure works. I hope that you learned something about Git today and the internal structure of Git. I really hope that you found this interesting, and subscribe if you haven't done that yet, and I really hope to see you in the next one.